Hey guys, Mr. Calbeck here. Welcome back to Calbeckistan, where anybody can learn math. So today's lesson, we're going to be taking a look at a problem like this. These are called rational expressions. Rational comes from the word ratio, and ratios are always fractions. So basically, you see the word rational expression, it means big, ugly fraction. And so what we're going to try to do here is break this down as simply as possible so that you guys can solve this kind of question today. We'll finish up with a couple of practice problems at the end so you guys can see if you can do it. But before we get to this kind of question, we need to break this down into something a little bit more simple. So let's take a look at a simpler case of adding fractions. I think if we can understand that, that will help us. So let's take a look at this question here. A little bit simpler, a little bit easier, and hopefully we can remember back to 4th grade when we learned how to add and subtract fractions anyways. Here's the problem. I think most elementary school teachers do a really bad job of teaching fractions. So we never actually understand why they work. And I think there's these little pieces about fractions that are a little annoying. And so it never clicks with us, which is why we never remember it. So let's look and see if we can understand what's really going on when you add fractions together. The first piece that your teachers always tell you is to find a common denominator. Now, I ask my students this a lot of the time, and very few of them actually understand why you can do this. So, for example, they would say, oh, you multiply this side by 2, okay? And then you need to multiply the bottom by 2 as well. And this is where it gets a little bit weird, because normally in math, if we're going to do something to one side, we have to do it to the other side. Those of you who remember my class, I always talk about the golden rule of math. That which you do to one side, you must do to the other side. So we've got our problem here. And what we're doing is we're multiplying, it seems like we're multiplying this side by 2. We're not doing anything to anything else. In fact, we don't even have another side. Like typically, when we do a problem, something like this. We look at a problem like this. Now, most of you would say, oh, we need to subtract 5 from both sides. And we're doing that here. We're multiplying, so we're subtracting 5, it all works out, it cancels out the 5 here. 5 minus 5 is 0. And you guys can solve from here. 2x equals 4. Divide by 2, because we're doing the opposite of multiplication. And you get x equals 2, which that's easy. But in this problem here, we seem to be doing something to one part of the equation, and we're not doing it to anything else. And there's not even another equal sign here that we can do to the other side. So it feels really weird to us. And the truth is there's a hack that most math teachers never tell you about why this is allowed to happen. Because the truth is here, we're not actually multiplying this problem by 2. We're multiplying it by 1. When we multiply fractions, you multiply them straight across. So what I'm really doing here is I'm taking 2 and dividing it by 2, and I'm multiplying that. But 2 divided by 2 is 1. What I'm really doing here is I'm multiplying by 1. Anytime you multiply by 1, you're not actually changing the problem, which is why we're allowed to do this. Most people feel like, oh, there's this trick, oh, you just had to learn it or something, common denominators. It's really confusing, but what we're doing is it's a hack. We're trying to change this problem so that it looks like the other one, but we want to do it where we don't change the value. So if we multiply by 1, we don't change the value, which then allows us to solve this. 2 times 1 is 2, 2 times 2 is 4, and we have 3 over 4. This problem now, hopefully you remember from middle school and elementary school. When you add fractions, all you do is add the top part called the numerator. If you add the numerators together, which then would give me 5 fourths. Okay, just like if I have 2 quarters and I add 3 quarters to it, I get 5 quarters. All right? Remember not to add the denominators. So you have your 5 fourths. Also, if you're in Algebra 2 or Algebra 1, please don't write it like this. You just don't need to do that anymore. So let's go ahead and go back to our original problem. And we'll see if we can apply this concept of the big one. So we see here we've got a problem with this. Now, what I always tell my students when they're doing these kinds of questions, whenever you're doing anything with a rational expression or rational function, you should factor everything you can first. And in this problem, there's only one thing you can actually factor here. For those of you who just said in your head, it's the second one. So let's go ahead and factor this. Both of these are divisible by 4, so I'm going to go ahead and factor a 4 out of this. And you can always check your factoring to see if you did it correctly by multiplying it back in. It should give you what you started with. So right now what I'm looking at is I'm looking at two fractions. They have different denominators. I need to figure out how to make them the same. And I'm hoping that you can see that this one has a 4 and this one doesn't. So what you need to do is give this one a 4. But remember, you can't just change things however you want. You have to follow the rules of math. And the only way I can change this, or I can make this look different without changing it, is to multiply by 1. So I'm going to multiply big 1 here. All you have to figure out is what goes in that big 1. Maybe you can think about that right now for a second. Hopefully it's pretty easy, and you realize it should be 4 over 4. Now at this point, put parentheses around this. Remember, you have to multiply the entire denominator. So we can multiply straight across here. So I've got 4 times 5, that's 20. Bottom is going to be 4 times x minus 7. You can distribute this if you want, but you don't have to. Over 3 plus 4 times x minus 7. Now you see I have a common denominator. And just like our problem before, when you're adding fractions, you don't add the denominators. All you do is add the numerators. So we're left here with 20 plus 3, which is just equal to 23 over that denominator. Just like in the last problem, where we had 5 over 4. And that's a simple case. The trick here that you have to realize is there's a hack. You're always going to be multiplying by 1 somehow to find a common denominator, and when you do that, you can add the numerators together. All right, that's a quick primer. I'm going to show you a couple of practice problems here. See if you can try them on your own and see what you can do. We'll have another video later with just more challenging versions of these same problems. So I want you guys to try this problem right here. Remember, when we're adding fractions, we need to find a common denominator. In order to do that, I think the easiest way is to factor everything that you can, and then find a big 1 that will make both sides of the fraction the same denominator. So go ahead and press pause right now. Maybe you can try this on your own. I'm going to show you the solution in just a minute. All right, hopefully you were able to get this. If you want to just check to see your answer, feel free to fast forward to the end of this problem. So what I want to start with in this problem here is I want to factor everything. I can factor both of these. I can see I can factor a 4 from this one. It's 8x and 12 here. So I've got 4, and then that's going to be a 2x minus 3. And over here, I can factor this as well, and I can see that this one would be 2 times 2x minus 3. So the denominators are already really close together. The only thing that's missing is this one has a 2, and this one has a 4. So let's go ahead and rewrite this so we can see what's going on. And this is over 3x, and this is over 2x. So there's a couple of ways you can go about doing this, but I think probably the easiest way is to multiply this one by a big one that has 2's inside of it. Okay, so remember our hack, we can multiply anything we want by 1 without changing the number. And inside this, I want to multiply by 2. And that's going to give us a common denominator. So let's see what this looks like. So I've got a 3x here and a 4x minus 3. When I multiply this one by 2, 2x times 2 gives you 4x. This times 2, again, all you need to do is multiply the constant terms together. Just going to give you a 4. Now that you have a common denominator, you can add the numerators together. 3x and 4x makes 7x over 4 times 2x minus 3. And that's your answer. Again, feel free to distribute this bottom piece if you want to. Not necessary, though. Also, box your answers for your teacher's sake. We'd really like to see boxed answers so we don't have to hunt all over your paper for the right answer. We really appreciate that. I'm going to try one more. It'll be a little bit more challenging. All right, now that you guys have seen this problem, I want you guys to see if you can do it on your own. Press pause. Try this on your own. I'll show you the solution in a minute. But remember, find a common denominator, multiply by that big one, then add the numerators. All right, this one's a little trickier because you had to factor x squared minus 16. For some of you who have had trouble factoring, it might be good to remember we got this invisible 0x in this problem, which might help you factor a little bit more. So we're looking for two things that multiply to be negative 16, add to be 0. The solution is x minus 4, x plus 4. This is a very special kind of factoring problem. It's called the difference of squares. Anytime you see something that's squared minus something else that's squared, you can use this trick. Notice the square root of 16 is 4, and then adding or subtracting that. The square root of x squared is x. This is a really common thing you'll see in problems like this. They love to throw that in there just to see if you remember the difference of squares. So, let's see if we've got this one. So instead of x squared minus 16, I'm going to write x plus 4 and x minus 4 in here. Just in my little fraction bar. Wow, that's terrible. Well, those of you who know me as a teacher, that's not unexpected. All that we're looking at here, we have x plus 4 and x plus 4 here. That's already the same. The thing this side doesn't have is the x minus 4. So the big one that I want to do in this problem is going to be a really big one. I want it to have x minus 4 in it. If I can get a big 1 with that inside of it, now I can solve this question. So let's see if we can finish this up here. So if we multiply this side, I'm just going to leave this in factored form. All I'm really going to do is multiply the top. Remember, since this is in parentheses, even though it's on the right side, you still need to distribute. So this 2 is going to multiply into both pieces, which gives you 2x minus 8. Now we have a common denominator where they're the same. So all I really want to do is add this 6x as well. So now that I have that common denominator, it just stays there. Again, it looks ugly. Try not to panic if you see a problem that's ugly. Don't make up new rules. Try to stick with the things that you learned. All right? Sorry, it should have been a 6x. I apologize. So 2x and 6x, we can combine those, and that's going to give us 8x minus 8 all over x minus 4 and x plus 4. Of course, you're going to be good to your math teachers and box your answers. All right, that's all the practice I have for you today. Again, we'll come back with a video later that's going to be with some more challenging versions of this same kind of problem. But what you're going to find is almost all these problems the same idea. Look for common denominator, and you can get it by multiplying by big 1. Anyways, thanks for watching. Hit a like, share with your friends. We'd really appreciate that. And good luck out there.